Kia ora koutou, everybody. I think we'll get going. Welcome to the second of our Passive House series webinars. My name is Murray Robertson. I am the board chair of the Passive House Institute of New Zealand. Te tuputanga o te wharikoru ki Aotearoa. I will also be your MC for this evening. Today, we continue to explore the potential of social housing. We have four speakers for you today. First of all, we have Tim Ross and Sam Parrish will be telling us the synergies and benefits of passive house and social housing. Rather wonderfully, we've got Thomas O'Brien and possibly his daughter Hazel as well, joining us all the way from Canada. Thanks, Thomas, for making the time to see us, to tell us about the wonderful Indigenous housing project in Canada. And then our last speaker, Jason Quinn, will be explaining the learning so far from the Kāinga Ora passive house projects. We'll be doing Q&A. If we have time, we might do Q&A as we go through. I'll be curating your questions, so please start putting them into the Q&A section of the webinar, and we'll have the bulk of our questions at the end. But first of all, I'd like to introduce our wonderful sponsor, Stein van der Eden from Simonite. And Stein, I'd like to ask you to say a few words.
Hey, yeah, thanks, Ray. Yeah, we are Simonite is a company. We're a contractor. We are quite excited to sponsor the event. We really believe that time is now to change things in construction. We believe social housing, which is the application of housing where people need mostly to be protected, to have good systems to take control away from them, is basically the field where passive house is most needed. So yeah, we're quite happy to be able to help out with the webinar here. And yeah, I'm just sharing a little bit my screen. For us, working passive house has been quite a journey. We had to develop a lot of new systems and ideas. But funnily enough, as a contractor, doing that work up front and seeing that design and detailing is well done at the end of the ride really gives nothing but advantages. There's less liabilities. There is a much better performance. There's less risk into our systems, our designs, and we're really starting to feel a genuine interest in doing better construction in facades. And yeah, that's our little feature here. So I hope everything goes well, Ray, and yeah, I'm looking forward to hear about all the projects.
Thank you, Stein. It's really wonderful to have you here today. I had a good look at your website yesterday, and one of the things I found with Passive House is that there's my video. One of the things that I found with Passive House is that it's getting the right information, and so the fact that you actually have qualified Passive House people in house and are able to provide that information is just so valuable. So it's great to have you on board. Right, let's get into it. I'd like to introduce Tim Ross and Sam Parrish, who are going to tell us more about why we should be doing passive house social housing.
Cool. Okay, I'll just be sharing my screen and hopefully this works out. Okay. Cool. So yeah, hi everyone. My name is Tim Ross. I'm a director of a practice called Archetype from Dunedin, and we're a practice which specialises in the design of high performance and passive house building. And today I'm going to be co-presenting with Sam Parrish from our office on the very topical subject of passive house and social housing. When we're going to have a specific focus basically on the benefits and the synergies, and basically why we think that passive house is a great fit for social housing, even more so than other building typologies. As we all know, over the last decade, house prices and rents have risen dramatically to the point where a lot of people are finding themselves locked out of the housing market or finding it very difficult to find affordable rentals. And to address this issue, decision makers have begun the process of building a greater number of subsidised housing units. Archetype have been fortunate to be involved in a number of social housing projects, as well as student accommodation projects that have similar budget constraints and programs. And some of these have been designed to the building code standard, while a number of them have been designed to the passive house standard. So for us, it's been quite an interesting journey to do the analysis of the potential benefits of co-built versus passive house projects when some of them have a lot of similarities, and to sort of understand the implications of up-speccing designs from code to passive house. And having gone through this journey on a number of projects, we now believe more than ever that passive house in general, while passive house in general offers great benefits to building owners, passive house social housing offers significant additional benefits, which should make it the obvious performance target for any social housing project. So as I said, I'm going to cover off the benefits side of the equation, and then after I'm finished, Sam's going to talk about some of the technical synergies that we've found while working on these projects, reasons why there happens to be just a really nice fit between high performance and social housing. So you'll have to bear with me a little bit, because some of the benefits that I'm going to run through are fairly well known by anyone in the passive house community. They're not particularly special, but I do think that they have a bit more resonance when viewed through a social housing lens. Okay, so the first one is probably the most obvious, is that passive house basically eliminates fuel poverty, which is obviously a huge benefit in social housing, where you've got people on low incomes. The image here is from Toiora co-housing, and while strictly speaking the project wasn't social housing, one of the units in this block was actually sold to the Dunedin City Council as a social housing unit. And just to illustrate this point about fuel poverty, I was talking to one of the residents at Toiora the other day, and this woman is a pensioner. She's on very limited income. She moved from a big drafty bungalow to a one-bedroom house in the neighbourhood. And in June last year, right in the middle of winter, a Dunedin winter, she spent $25 on energy for the month. So that's including cooking, hot water, space heating, and I think that's pretty incredible. I find that kind of thing very satisfying. So just to put the term fuel poverty in context, fuel poverty is when families are spending more than 10% of their income on energy in order to keep their houses at least 21 degrees in the living areas and at least 18 degrees in the bedroom areas. And this particular woman was spending 7 times less than that, less than the threshold of fuel poverty. So it's pretty exciting to see that the impact that it can have on people's lives. And one of the reasons that fuel poverty can be particularly tough on people in social housing is that they do tend to be people who stay home for longer periods during the day. Examples are caregivers with small children, older people, beneficiaries. So that means that they have to keep their houses, they have to heat their houses all day during the heating months, and therefore this obviously requires more energy. But on the flip side of that, from a passive house point of view, it means that every dollar of insulation you put into social housing provides more benefit than say insulation that was put into a house that's not occupied during the day. So again, another really nice fit there between social housing and passive house. And when we say derived more benefit, we're not just talking about comfort and general improvement in quality of life. The World Health Organization guidelines point out that, that poor housing or housing that's expensive to heat contributes to poor cardiovascular outcomes and other health outcomes. And WHO guidelines say that, I'm going to have to see my notes a bit better. Poor housing conditions are one of the mechanisms through which social environmental inequality translates to health inequality, which further affects the quality of life and well-being of people. So to put it another way, by building to the Passive House standard, decision makers are able to effectively tackle one of the mechanisms that contributes to making poorer people have poorer health, which I think is quite exciting. You can really just, even if people end up on low incomes or on low incomes, they don't need to have the associated poor health if they've got good housing. So those are just three of the benefits from an occupant point of view. But obviously, if we want to have developers and the local government building these things on a larger scale, we need to talk about the benefits for the building owner as well as the occupant. So we've been working for a number of developers on Passive House projects, Passive House social housing projects, and we've found that there are some significant benefits for the owners. Firstly, it's important to note that one of the reasons that social housing is so well suited to Passive House is that it's almost always developed with the intention of holding and maintaining the asset for a long-term period rather than for quick resale. And that means that social housing providers think differently about their assets from speculative developers. The developers at the Leith Street student accommodation project shown here have built a number of student accommodation buildings in Dunedin in the past. They build to own them, not to sell them. And what convinced them of the value of high performance building was that they'd seen a number of their brand new apartments suffer from problems with mold, condensation, students not opening the windows if they're out all day. And so in order to address this, they actually started putting in Passive House ventilation systems into their new apartments, even if they were just built to code. And that obviously helped alleviate the problems with condensation. But from our point of view, it was brilliant because it gave us an inroad to be able to say, well, look, if you're already putting these ventilation systems in your unit, well, why don't you spend a little bit more on air tightness membranes, improve your windows, and then you'll barely need to heat your apartments. And that's what we did. And from there, the developer came up with a rental model whereby they could include the electricity costs and the heating costs in the rental of the apartments, and that was used to justify the extra investment in better quality windows, in this case triple glazed windows, and air tightness membranes. And for all of our Passive House projects, Passive House multi-residential projects, we've designed district hot water heat pump systems. Again, these are marginally more expensive than individual electric cylinders, but they are 3 to 4 times as efficient as direct electric heating and avoid the need for huge numbers of condensers if you're going to, say, put heat pumps in each of the units. One larger commercial system feeds a ring main that can be fed through the entire building. And again, the landlord can benefit from this additional investment and include the rent and the hot water into the cost fee renting the apartments. Next benefit is happier tenants and lower rental turnover. We don't yet have a lot of data about the rental of Passive House apartments in New Zealand, but overseas data would suggest that occupants of Passive House developments are significantly more satisfied than occupants of standard housing developments, and therefore they stay put for longer, which is a big plus for landlords. And then Passive House also suits landlords with climate, health and wellbeing objectives such as central government and local councils who are under pressure from their constituents to show leadership in the transition to a low carbon economy. This project is for the Dunedin City Council. It's 10 pensioner flats. The project has completed its pre-construction review by Sustainable Engineering. As you can see, we've got 2 identical blocks on the site. They're accessed from the central courtyard area, and they've all got nice outdoor decks which face northeast and northwest, the sun. Here's a photo taken the other day of one of the units from the courtyard side, the front door. They're rapidly approaching completion, and these are going to drastically reduce the energy demand from the other pensioner flats that are owned by the Dunedin City Council. Here's a view of the outdoor living side with the external landscaping underway, yet to be planted. A couple of shots from inside. As you can see, they're just finishing up these units now. What's really exciting about this is that these homes are, this envelope will be warm and dry for 50, 60, 70 years for the life of the building. Pretty much inherently, I find it, exceptionally exciting. Another shot of one of the bedrooms. So the final blow test for this project is programmed in the next couple of weeks. So fingers crossed we can get that ticked off. Yeah, so in summary, those are some of the practical reasons why we think passive house is so well suited to social housing for both building users and owners. And I'm now going to hand over to Sam to discuss some of the technical synergies that we have discovered that make the passive house the obvious performance target for any social housing project. Sam.
Well, thanks, Tim. So yeah, while Tim discussed some of the benefits for occupants and owners of the work in our space, our work in this space has brought us to the realization that there are also a lot of solid technical reasons why passive house fits really well with the social housing. As you may have noticed from Tim's part of the talk, all of these projects that we've shown are medium density multi-unit developments. While much of the current social housing stock in New Zealand is comprised of detached homes, the bulk of future social housing supply will undoubtedly be in the form of townhouses and apartments. I mean, there are some obvious reasons for pursuing medium density development for social housing. Mainly, they make more efficient use of available land, which can contribute significantly to the overall cost of a build. They can also benefit from greater economies of scale, not only in materials, but in systems that would not be suitable for small developments. And then we've had a number of developers approach us for social housing projects with a brief of medium density, 3-story walk up or similar that have had no interest in passive house whatsoever to start off with. But when we've kind of said to them, actually, the low surface area to volume ratios of these projects mean that thermal performance, you don't have to add additional insulation. It's really easy to kind of convince them then just passive house certification is just common sense. I mean, for example, here are a few projects that we've been working on the last couple of years. The first example in the top left is a single-story code minimum unit for a developer in Dunedin. The form factor of this is 3.4. So form factor is just the ratio of the thermal envelope to the usable floor area and kind of describes, how much energy, I guess, would be, or how efficient the shape of the building is. So the next two to the right of that are both Passive House Plus certified projects. The first one has an awkward thermal envelope with a garage kind of underneath it, so there's overhangs and bits sticking out. This one also has a form factor of 3.4 and required a higher R value of thermal insulation overall to achieve the passive house requirements. The furthest to the top right is getting close to sort of the ideal single residential thing. It's essentially a cube over 2 stories. I don't know how much better you could get in terms of a form factor for this, and yet it still required significant R values because Dunedin is so cold. I mean, the final two on the bottom slide are the School Street Pensioner Housing Project and the Leith Street Student Accommodation. As you can see, the School Street project has a form factor of 3.6, which is actually worse than the original code minimum project. But I mean, it's not easy to kind of get a good form factor on single story projects. However, the average R value to reach passive house was 2.8 because there's less sort of external elements per unit. And finally, the Leith Street has a form factor of 1.9, so anything under 2 is sort of excellent. As it's a 3-story walk up, most of the units lose heat from the front and the back rather than from the external spaces. One other interesting synergy that we discovered was around window selection on these projects. One of the most significant extra costs in a passive house can be the windows. it can be hard to make the case for high quality windows, often with triple glazing based purely on thermal grounds. You inevitably get the pushback that aren't standard thermally broken windows good enough. What we have found is that by focusing on the acoustic benefits of high performance windows, so triple glazing, airtight frames, you can frequently justify these to clients. Again, this is frequently more important for social housing, as they are located on more marginal sites with busy streets or transport corridors. At Toyota co-housing, we feel as though we could have justified the triple glazing on the project purely from an acoustic point of view, even if the thermal performance hadn't been considered. This project is in Beaumont's Way in Manarewa. It's directly adjacent to a rail corridor. And the council basically said we had to prove that the apartments would not overheat in the summer without the need to open the windows. Though this wasn't going to be a certified passive house project, we were able to convince the developers to include mechanical heat recovery ventilation systems in each of the apartments purely for the acoustic reasons, so the occupants could keep their windows closed to keep out train noise and still have fresh air supply. We put together a quick sort of PHPP model to show that with the shading and more importantly with the ventilation systems, we were more than capable of keeping the internal temperatures comfortable without requiring opening of the windows. And this also is a benefit where there isn't a particular sort of nuisance noise source in the area. As the higher the density development, there are likely to be more on-site noise sources from neighbors. So having the option to be able to keep your windows closed leads to greater occupant comfort. As Tim mentioned, the majority of the social housing projects are built with rental models in mind. And as such, they're required to comply with the, at times, more strenuous Healthy Home standard. The ventilation standard requires, from Healthy Homes, requires extractor fans in both the bathrooms and the kitchens ducted to outside. But alternatively, you can now put in continuous mechanical ventilation systems to meet the requirement. These typically, because the passive the units or social housing units have smaller floor areas and volumes, both the passive house and Healthy Home standard ventilation requirements can be met with small, discrete ventilation systems that take up little room and are reasonably affordable. I mean, the Healthy Home standard also requires thermal modeling of the living space to prove that an adequate heat source has been provided. I don't know if you've used the heating assessment tool from the Healthy Home standard, but I mean, I find that the PHPP is only a little bit more complicated, but more accurately calculates the actual heating for the entire unit, not just the living room. The elements I just discussed using form to minimize insulation requirements using reasonable windows and a mechanical ventilation system are relatively easy to include as requirements in any social housing project, passive house or not. Airtightness is a trickier element as it's not well understood by the construction industry as a whole at the moment, and it is seen as another thing that needs to be added. The Healthy Home standard does have a requirement for ensuring that no unreasonable gaps or holes in the building elements, which is a good argument for airtightness building. But we find it's easier just to kind of detail the projects so that the contractor doesn't have to think about airtightness as an additional element. It's just part of it. On Lee Street, for instance, we specify cross-laminated timber floors and intertenancy walls. Initially, these were justified to the client because it allowed us to sneak under maximum height restrictions by creating high-performance acoustic floors at only 225 millimeters of depth. However, it also greatly simplified the airtightness as the panels themselves are internally airtight, and only the junctions or the junctions need to be taped. So each of these units was treated as its own little airtight envelope, which made it easier to test on site and find leaks. The initial testing for these all came in between 0.3 and 0.5 air changes per hour, with sort of the higher values on the top floors where you've also got a membrane ceiling, so it's slightly more complicated detailing. Solid timber also helps reduce thermal bridging at mid-floor and intertenancy walls. I mean, you can see from the top right detail here, the CLT extends all the way to the outside as you kind of need from a fire-rated intertenancy wall. But the timber means there is limited kind of thermal bridging there, whereas the detail we used on School Street, which used an AAC panel, required a lot more toing and froing with fire engineers, just because we didn't want to extend that essentially cold concrete panel all the way through to the outside and provide an area where cold can be brought into the center of the building. Though this is not a strictly passive house benefit, trying to minimize thermal bridging in junctions tends to favor timber construction, which also helps to reduce embodied carbon compared to concrete and steel. So as you can see, that many ways in which passive house proves to be a great fit for social housing. While this list is by no means exhaustive, it demonstrates why we now believe that passive house standards should be the obvious performance target for any social housing project. Thank you for your time, and hopefully we now have some time for some questions.
Thank you, Tim. Thank you, Sam. Yes, I think we've got a couple of minutes for some questions, and we have a couple of questions. The first one's from Karen. He'd be interested to know more about the details of the Beaumont's overheating study.
So we basically just kind of did a very, very quick rough PHPP and just checked to make sure that it wasn't over that sort of 10% or 10% of the year over 25. So again, it was just a very rough look into it. It wasn't a full sort of PHPP model.
And we've got a few questions coming through on the chat as well. Was there any acoustic detriment from the MVHR in the Beaumont Road project? I.e. drawing in the railway sound. Did you have baffles or anything, or?
Yeah, so the system that we used has like an acoustic attenuator built into it. So you've basically, because it's a, what's it called? Balanced ventilation system. You've already got the core that all the sound has to go through anyway, but it's then got an attenuator. So rather than having a direct hole to outside, you've got a number of layers that the sound would have to kind of transition through before it then gets into the building.
There is a question about which CLT supplier you used and what thickness of panel. Presumably it would be airtight.
Yep, so we used XLAM because they were really the only people in the country at the time, and it was 110 mil panel.
Right.
So there was a couple. Oh, yeah.
Sorry, you go.
I was just gonna say there were a couple of holes or lifting holes and stuff like that that needed to be taped, but otherwise it was just long joins.
Yeah. Were they obviously used for the big internal walls between apartments and the external walls? Was that correct?
Yep. Yep. So it was just the intertenancy walls and the floor slabs. So all the external walls were just traditional timber framing, 140 mil.
Right. Oh, fantastic. I see there are a couple of more questions, but I do want to keep things running on time. So thank you, Tim. Thank you, Ross. It's fantastic to see what you're doing in Dunedin. We need to do more of this around the country. Great to see the investment models and the justifications and how that's been working out. Of course, less external wall area is going to be less cost as well. So getting your form right is also an economic thing. But we'll move on right now. I'd like to introduce Thomas O'Brien, all the way from Canada. So just so thankful that you're made time to come and talk to us today, Thomas. And you'll be telling us about the Nanaimo Aboriginal Centre. Hopefully I've got that pronunciation right.
Yes, thank you, Murray. Thanks for the intro. Yeah, my name is Thomas O'Brien. I'm the manager of housing and facilities for Nanaimo Aboriginal Centre. And I'm here to share about our Nuutsumuut Lelum project, the 25-unit multi-unit residential passive house certified building. So let me just work on this here. Let's see here. All right. Again, I just I'd squale. Good day, everybody. Thank you for allowing me to be here and speak about our passive house project. I just want to start by introducing myself again. My name is Thomas O'Brien. I'm the manager of housing and facilities for Nanaimo Aboriginal Center. I was born and raised on Treaty 6 territory in Edmonton, Alberta, Canada, and I now reside on the unceded traditional territory of the Nanaimo First Nation in Nanaimo, BC. At Nanaimo Aboriginal Center, we recognize the traditional territories of the Snuneymuxw, Snanawas, and Stamanis First Nations, as well as the chosen home of the Mid-Island Métis Nation. Just a brief introduction of our housing team at Nanaimo Aboriginal Center. Here you see Beth Harry, who is our housing administrator, and myself, the manager of our housing property. It's hard to see on the map here, but Nanaimo is located on the east side of Vancouver Island, facing Vancouver across the Georgia Strait. It's roughly 30 nautical miles of water in between the island and the mainland. Despite being about 8 degrees north of New York, Vancouver Island enjoys a cool temperate maritime climate. The northern location results in shorter days in the winter and longer days in the summer, which creates some challenges for solar heat gains and overheating. Heating season is longer but milder than New York's. Vancouver Island, picture on the left here you see. Vancouver Island is roughly 3 times the size of New York, the New York metropolitan area, with 4% of the population. Nanaimo, indicated in blue here on the map, is the second largest city with a population of 104,000 people, of whom 7,300 identify as indigenous. We share Vancouver Island with around 800 cougars, giving it the highest population density of mountain lions in North America, or approximately 1 cougar per 1,000 humans. There are no bridges or tunnels connecting Vancouver Island to the North American continent, and this contributes to our separation. Sorry, just a little fun facts here for you. Nanaimo is probably best known for its culinary export, the Nanaimo bar, but its recent history as a deepwater port for the coal and lumber industry in the 19th and 20th century overshadows its much longer history as home to the Snuneymuxw First Nation, on whose unceded traditional territory the city of Nanaimo and this project exists. Snuneymuxw First Nation is one of 50 recognized First Nations on Vancouver Island, each with its own distinct history, culture, and traditions, and that plurality of cultures is represented in this project. Nuutsumuut Lelum is Hulkaminum. Translated from Hulkaminum to English means Nuutsumuut, all in one, Lelum meaning house. So translates to all in one house. Here's an initial conceptual project drawing of Nuutsumuut Lelum. From 2015, Nuutsumuut Lelum was funded by BC Housing to include 25 units of affordable housing with an amenity room space built into the project. It consists of studio bachelor suites, up to 3-bedroom units for families. On the property, there are 3 townhouse buildings that make up all the buildings on the property, that are ground oriented with ground level access, and with a gross floor area of 26,500 square feet. At the time of construction, we were able to build the project at about $195 per square foot. So with Nanaimo Aboriginal Center, BC Housing, support of the City of Nanaimo, our architect, DYS Architecture, Mark Ashby, who was our CPHD for the project, and Saywell Construction, who was our general contractor, with Herald Engineering and Designed Air Systems, were our project tradespeople for Nuutsumuut Lelum. Site selection plays a major role in the ability to meet the standard. Our site is an elongated sliver with Bowen Road to the south, south-facing residents to the north, and an access drive to the west here, and a gully with a riparian setback to the west. Bowen Road, here down at the bottom of the picture, is a busy artery, a main artery through Nanaimo, and with good solar access on the side with unrestricted, unprotected openings. Suitable for passive house and also inexpensive. Probably daily, we have upwards of 20,000 vehicles that pass by our property every day. And having been in the units now post occupancy, the triple glazed doors and windows, it really lessens the noise that you hear from the traffic going by every day. It's actually quite surprising of just how quiet and suitable it is inside the units that are along Bowen Road. So here's a little by the numbers graphs for you guys with a site cross section of our project. So total floor area is 1,966 meters square. I'll be honest with you, I'm not a passive house expert by any means, so I'm not fully understanding some of these numbers, but just to be clear, I think some of you guys will understand some of the numbers here that we're speaking about on the right-hand side over here. So each unit at Nuutsumuut Lelum has a Zender Comfo Air 200 HRV unit in each unit, and our amenity room space has a Zender Comfo Air 550. It's a larger space where we have community gatherings, as you'll see further down. And we also have, each unit has a sand and CO2 heat pump that supports each unit. Nanaimo Aboriginal Center's vision for Nuutsumuut Lelum was and remains to create safe, affordable, and culturally appropriate housing for our urban Indigenous population in Nanaimo, while building community for those living away from home. As I mentioned, Nuutsumuut Lelum has 25 units of affordable housing that includes 4 studio suites that are geared for youth aged 18 to 25 transitioning from care to independent living, 6 one-bedroom units. 3 of the one-bedroom units are designated for elders, 3 two-bedroom units, and 12 three-bedroom suites for families. Our vision for having the 4 studio units for youth, as well as designated elder suites, was to create intergenerational connection between youth, young people and elders, and to be able to share teachings and knowledge passing down from our elders to our young people. Here you see the amenity room space, which we call the Chukwa room. We recently did a naming ceremony. Chukwa is Nuutsumuut, meaning come in, safe space. So the Chukwa room was designed to provide space for our Nuutsumuut Lelum families to host gatherings such as dinners, barbecues, birthday parties, and celebrations that they may not be able to support inside their unit. cultural gatherings. Here you see pictures of Nanaimo Aboriginal Center's Hishu Kish Sawak dance group, bringing the good medicine of song, dance, drumming, and prayers to our Nuutsumuut Lelum community. Hishu Kish Sawak is Nuutsumuut and translated to English means we are all connected, we are all one, meaning the land, the sea, plants, animals, insects, and human beings, all connected. Nanaimo Aboriginal Center also organizes community gatherings that include Easter egg hunts, Halloween celebrations, Thanksgiving and Christmas dinners, barbecues, craft nights, youth nights, homework club, coffee talk groups for parents, junior youth empowerment club, National Indigenous Peoples Day celebrations, which is all done in partnership with other community organizations. At NAC, we deeply believe in partnerships and nothing we do is without collaboration. We deeply believe we are stronger when we work together. Here you see in the picture in the top right corner is the totem pole that we have on property at Nuutsumuut Lelum. The figures from the top to the bottom, we have a human, raven, eagle, and a beaver with a frog on its back. The human is a First Nations person. The raven brought us the light. The eagle watches over us and carries our prayers up to the Creator. The beaver teaches us how to work as well as how to paddle. The frog is the voice of the people. The design for this totem pole was chosen under the advice of elders, which reflects animals and legends of the area. This totem pole was carved by Noel Brown, who's a local Nanaimo First Nation master carver. Noel Brown is a member of the Nanaimo First Nation located on the east coast of Vancouver Island. He comes from a long line of traditional carvers and artists, both Coast Salish and Quaggalth. Noel has been trained by master carvers Richard Baker, Matthew Baker, and Doran Lewis. He draws inspiration from James Christopher Lewis and is guided by his elders. Noel has been professionally carving since 1995. He uses a variety of mediums such as wood, metal, ceramic, canvas, silver, and gold. His art has been installed in many public places throughout Nanaimo, and he has approximately 12 totem poles and a variety of other art pieces located in city parks and commercial buildings. His youngest son is currently apprenticing under him, and he is also mentoring several youth. You can also see in the picture here that the project has cedar cladding as siding. Cedar is a very important material that's used obviously for construction, but it plays a very important part in traditional Coast Salish culture. The architecture of the building that you can see here a little bit is representative of traditional Coast Salish longhouses. And down here on the right, this is a ceremonial entrance, traditional ceremonial entrance to enter into the Chukwa room from the Bowen Road side. Métis art installations. Kelty Chamberlain is a Métis artist who was commissioned to create the two Métis art installations at Nuutsumuut Lelum. Together, the pieces are called Woven Connections. The first picture on the left is of woven cedar, representing the Métis sash with traditional colors and patterns. The second picture on the right is a metal fabrication and a representation of the Alberta rose found in traditional beadwork. The patterns of spears are indicative of the diaspora of Métis, and the collection in the center represent the strength we have when we stand together. Fabricators Brett Chamberlain and Sol Sharp help bring Kelty's vision to life. Nanaimo Aboriginal Center was awarded the 2018 BC Nonprofit Housing Association Housing Provider of the Year Award for the work being done with the Nuutsumuut Lelum community. In 2019, NAC was awarded the 2019 Vancouver Island Real Estate Board Commercial Building Award of Excellence for multifamily non-market for the Nuutsumuut Lelum building. Post-construction and over some hard work and through a rigorous effort, we did receive our certification for Passive House for Nuutsumuut Lelum, the first multi-unit residential building certified Passive House, we believe to be in British Columbia and possibly in Canada. Something we're very, very happy of. And on the right here, you'll see what we recently been doing some work to gather both aggregate data for all 25 units here, as well as our house meter into what's known as Energy Star Portfolio Manager. And this is, we just finished gathering all the data and inputting it. And this is the energy scorecard that we received. Nuutsumuut Lelum is a fully electrified property. There's no gas or fossil fuels being utilized on the property. But our portfolio scorecard is 86. And as you can see here, right here, that's our threshold there at 86. And this little blue dot here you see is provincial average for similar multi-unit residential buildings throughout the province that, of course, are not Passive House standard, but you can see they're just slightly above 200, and all our data that we've gathered show that we're performing just about at 86 right now, which is well below the provincial average for similar sized buildings in the province. So good news. The intention of the project and the real world data that we've gathered post occupancy and a few years post construction, which was June 2018, shows that the building is currently performing as expected or intended to.
Right. I think my video just won't turn on, but thank you, Thomas, for that presentation. It was, thank you for just sharing about the project and also about your community and culture. I think the way that they've gone hand in hand is so fantastic. Somebody did make a comment about how important the intergenerational aspect of your work is. And it was great to see that, I guess, the sense of belonging and community that looks like you have created. I love the word that you had for your amenities room. It's a welcome, come in, safe place. It's a great great name. Do you think you'd be able to tell us a little bit about what you've seen as far as the effects of this project on your community, how it's benefited the inhabitants of the housing, and both from I guess a health point of view and a community point of view?
Yeah, so I can share probably a couple of stories here with you, but so here in Canada and in Nanaimo in British Columbia, we have BC Hydro, which is our electricity provider. And to speak to the current utility costs, you know, one of our thoughts and our vision was obviously to build safe, affordable, and culturally appropriate housing. So the idea on trying to seek passive house standards and while building affordable housing. I mean, you can have affordable rents that people are being able to afford, but if your utility costs are sky high, it kind of takes away and doesn't balance itself out. And the information that we've been sharing, all our tenants here on the property are responsible for their own hydro. They each have their own hydro meter for the units. And here in Canada, I'm not sure how it is in New Zealand, but we're billed every 2 months. So you get 6 hydro bills a year. And information that I've been gathering from tenants, on average, for a 1-bedroom unit is about $41, and said maybe 47 throughout the winter. So you're looking on average, you're looking at maybe $22.50 a month. And then some 3-bedroom units is upwards of, 125 to 180, depending on obviously the way they live and what they have inside their unit. But compared to our average hydro bills out in other communities and other housing is substantially a lot lower than what other people are paying. So that's been a benefit. So our families have been able to save money, save up for cars, and being able to afford the groceries or things, being able to go out and do activities that they might otherwise not be able to afford to do, especially with, the cost of living rising right now. It's been really bad here in British Columbia. Our gas prices are through the roof, and then everything else goes up with that for food and stuff. Other members of the community have been able to go back to school and seek their education, being able to afford transportation and buses to get to and from school. So there's been a lot of benefits for that, from savings that they're seeing from the utilities that they've been able to apply to other things in their lives. And health benefits. So another property that we used to run that has been now closed down. We had moved, and I've been given permission to share this story today and previously. So we had a single mother of 2 children that has a pretty serious skin condition that is affected by her living environment. So we had an opportunity to transition her into this property from the old property when people were being relocated. And she shared with us through the benefits of obviously the HRV and the passive house environment. Since she's moved here, she's now been here 2 years. She's had minimal flare-ups. Her skin condition has gotten better, in fact, and she's being able to live a healthier life and benefit her children better, living day to day as a single mother, and the responsibilities that come with that, because she's not being held back by the effects of her condition. So I believe it is definitely in relation to the healthy living environment, with the clean air being filtered through the HRV and provided back into the space. And it's just, it's been incredible. So, I mean, that's one good story of benefits, health, like direct benefits. And I've seen it, her better and picking herself up. And it was pretty special to be able to kind of witness that. Of course, it had taken a couple months, but then she was just like so happy and just saying, "Oh my goodness, thank you for allowing us to live here and move here. It's been so much better for me." And she's been able to be a real contributing member of the community, and she's become a pillar around here, and really stepping up for her children as well.
That's really fantastic. We often talk about just mention fuel poverty and lowering costs and stuff, but the fact that having done that, people's lives have been able to be transformed through their better health or been able to take an opportunity that they wouldn't have with education or something like that. To actually, hear the actual detail of the story is quite powerful. There are a couple of questions on the chat. Hydro, what does that consist of? Is it just water, or it must be more than that?
Yeah, so it's just electricity. So it would be so supplying the heat pumps, the electricity that powers the HRV units and the hot water storage tanks, lights, your oven, your stove, your refrigerator, all that stuff.
Right.
And then I like your TVs and your video game systems. And
Yeah.
I don't play video games, but
Yeah, those bigger TVs, they take more.
yeah.
There's a question comparing Energy Star assessment with Passive House assessment. How do they differ? What would be needed for a 10% improvement suggested?
So that I just finished getting that and inputting that data. So that's our next step to look at. How can we get that 10% reduction? How can we work towards that? It's definitely been a work in progress. I started with the Nanaimo Aboriginal Center October 15th, 2018. So I'm just coming up on 4 years here, and started about 3 months post occupancy of the project. And I'm continually educating myself. I never even heard of Passive House before. My background wasn't actually in residential housing. It was in like commercial buildings and commercial properties and universities and stuff. But I'd never heard of Passive House. And so it's been a really steep learning curve for me to understand and educate myself. And I think the biggest piece, a challenge that we see is around the education piece and educating our families and our community on how the design of Passive House is intended to work. Like even operating the windows and the booster switches for the HRV units. And I go when I'm occupying new residents and teaching and explaining, and then we hold sessions to re-educate families that have continued to live here. And it has a hard time to grasp too, like when you go into the bathroom or the kitchen and you push the booster switch, which kicks the HRV into party mode, they'll push it and then you'll see them waiting to hear the equipment kick in, right? And they're like, that switch doesn't do anything. I'm like, and then I'll take them to the HRV room and I'll show them the panel and I'll see, now, oh, well, how come I didn't hear it? So going from, growing up and living in standard construction homes where, you turn the light switch on, the light comes on, you go to the thermostat and you turn your electric baseboard heater on, to, Passive House cooling techniques that we're trying to educate them on and how things operate here. They've been fundamentally trained or learned or grew up. You flick a switch and you see or you hear an action take place, right? That's been a bit of a challenge for us, but we're invested to continue to re-educate them and answer questions that they have and just go over that. And yeah,
that's fantastic. It's almost like electric cars. You need a false noise just to make it sound like it's doing something.
Right. Yeah.
There's another couple of questions. How did you didn't know about Passive House in advance, so how did you come to choose Passive House for this project?
So our previous executive director and a project team that they worked on a previous building, another building here in town that's not Passive House, but they were at a conference in Saskatchewan. I think Saskatchewan, where one of the first Passive House little buildings was built, and they were at a conference, and that's the first time that they heard of Passive House. And so our executive director connected with his project consultant and asked him, and our general contractor was like, no, I don't know what Passive House. So that intrigued them to start to learn more about it and what it was. And then when we went to the city of Nanaimo donated the land that this project sits on, and one of their requirements was that we did meet Passive House standards for it, or was built to Passive House standard. But yeah, so it was like, I think 2014, if I'm remembering correctly, was when they first started hearing about it. And then they just rolled with it and wanted to build, obviously, sustainable, safe, affordable housing, but obviously being thoughtful of, your carbon footprint and environmental impact. So yeah, he was a gentleman that once he sets his mind to something, it's just get out of the way, because he's going to get it done.
Oh, fantastic.
Yeah.
Yeah, we've got quite a strong Indigenous community in New Zealand. It's interesting to see the parallels, and there is quite a lot of iwi-based housing now being built. So the opportunities there, I think, here for Passive House also. I know that you may not be here at the end, so there's just a couple of quick questions before we move on and trying to squeeze them in. Do you happen to know what windows you used?
Yeah, so we used Euroline windows.
And also there's a question, was the developments alongside the river, I think, or the water, is there any physical connection acknowledged on the property?
Yeah, so actually when construction was, so the east end of the property where the river is, it's actually an archaeological site. We're not allowed to dig there or build on there any more than we have already. During construction, when they were grading the property out, we actually found it was a really important area for the First Nations in this area, this river, the Millstone River. And they found some artifacts that we had to, construction was halted and stopped. And then a local Nanaimo elder and the community was consulted and brought in to rebury the artifacts. And then the Ministry of I can't remember, the Ministry of Lands or something, deemed a certain part of the property an archaeological zone, and we had to go through, because we wanted to get a chain link fence built to just close in that area. That was like, I think, a 1.5 year process, and consulting the local First Nation, as well as to get approval just to have I think it was 14 posts dug and concreted in to fence in that area. But as far as that, we can't build anymore or dig down. You can't penetrate the ground.
Right. Yeah. Thanks, Thomas. I would like to keep going, or just maybe one quick question will sneak in. Has this project been a catalyst for any other projects in your area?
To Passive House standard?
Yeah. There are other projects now seeing what you've done, people deciding to.
Yeah, so I'm getting a lot and sharing a lot about our project and our story. But right now in Canada, there's a challenge. I mean, all over the world, we're in a real housing crisis up here, and projects that are currently federally funded are partnered with provincial funding. They've narrowed like your time frame to build. It's called the Rapid Housing Initiative right now. That was just announced in the federal budget the last couple of years. So a lot of people are going to modular builds, because once you get the land and you have a development permit, I think the time frame was start of construction to completion is like they're giving you like 12 to 18 months, which isn't a lot of time. So a lot of people are getting prefabricated and doing modular builds. But going more towards like net zero homes, well, we have one of our board members is building residential passive house. He's actually just completing, so single family dwellings. He's just completing his second passive house build, but it's just a single family dwelling, not a multi-unit residential building. So it's starting to gain life. I mean, obviously we'd like to see more passive house builds, multi-unit builds, and I see that you guys are doing some great work with some incredible projects down there in New Zealand, which is great to see. And yeah, it's just been great.
Yeah. Oh, thank you very much again, Thomas. We'll have to keep going, but I would like to talk more, but just really appreciate you being able to join us today. Thank you.
Yeah, thanks for the time and the invite to come and share, and appreciate it.
Yeah, thank you. Right, we'll continue on. We've now got very own rocket scientist Jason Quinn, who will be joining us. And he'll be telling us what the learnings so far have been on the Kāinga Ora projects in New Zealand.
All right. Hope you can all hear me pretty well. We'll give this a go. All right. Now, Murray, so maybe we can see that. Let me get started. So, Murray, can you just let me know? Do you want to finish at 120 still, or can I have a little bit more time?
I think you can have a little bit more time, and we've already had a good number of questions.
All right, so I'll plan on finishing my 125 at the latest. I'll cut it a bit short. So, yeah, so my name is Jason Quinn. I'm the Director of Sustainable Engineering, which has been the primary passive house certification organization here in New Zealand for quite a few years now. And I've been pretty blessed and lucky to be involved in, well, I guess all the certified passive house social housing projects in New Zealand. So we've done the pre-construction or the pre-certification stuff for 2 different Kāinga Ora projects, which we'll explain today. And I've pulled together our lessons learned as certifiers. I've also spoken to the passive house designers on both these projects, discussed their lessons learned, as well as some folks at Kāinga Ora and some of the architects as well. So although this is all mistakes in this presentation are mine, a lot of the good ideas are not mine. So although my voice will be the one speaking them, they're from a lot of folks. So please take that into consideration. So I wanted to start with this slide, which Brian Berg graciously let me use. This is a picture of Kāinga Ora's carbon continuum. And the reason I wanted to take time to look at this again is that effectively there's this big plan to do building for climate change from MB here in New Zealand, which is our government organization, Thomas, if you're still on, that's looking toward reducing energy use to help meet our climate change goals here in New Zealand. And effectively low energy building, PHI certified low energy building, which is twice the energy use of a passive house, is going to be something like the 2027 intermediate cap. Now, that's 5 years away, right? Not very far, especially if it takes you 3 or 4 years to build a building, and it takes you a couple of years to design them as well sometimes to get things going. So when Kāinga Ora went and looked at this and looked at the targets they needed to get ahead of it and do research. And unlike a small research organization or brands, they do research by building buildings and occupying them. So they've decided to go ahead and step out and do several different projects, 2 of which we're going to talk about today. One is Bada Ventura, which is intended to be certified to passive house. And one is Kāinga Ora, which is looking not only at passive house energy levels, but also at the embodied carbon and net zero energy with PV submission as well. So they've gone through and built out, well, they've started construction, and we'll go through that in a minute, as well as done this. And I've tried to pull together all the lessons learned for the project and put them into 3 different pieces. So the first set of pieces, which we'll look at just now, is the lessons learned from kind of the client level, the top level, looking across the projects. So from talking from people like Kāinga Ora and the architects and passive house designers as well, these are kind of the 5 lessons we boiled down to that are kind of the top level ones that have gotten so far. The biggest one, and it was kind of interesting to me because I didn't really think about it until it was pointed out to me, is that the thing they've learned is that this is how great housing can be someday. So, if you're trying to get somewhere, it's certainly a lot easier for people to look where you're going or to know where you're trying to get to rather than knowing how far like how much further away from my house I am. It doesn't really help me unless I know where I'm going, right? So if you want to get somewhere, it's much better to navigate if you know where you're going. So it's really changed their lens at which they look at housing quite a bit. The second lesson learned they had was the importance of a whole systems approach rather than looking at a line by line meeting the building code. It's really common in consulting, especially when you're doing projects. If you get a project, you get a set of requirements from the person who wants a project. And you basically, every time there's a shall clause in a contract that says you shall do this, you shall do this, well, you write it out and you make sure you do that stuff. Anything else that's not with a shall clause, you don't do it. So oftentimes when people are building buildings to code compliance, their focus is those words, code compliance. So they're looking at how can I meet each of these separate clauses? Whereas by using a passive house systems level approach, a whole of systems approach, you can look at satisfying everything at once with multiple solutions. They also felt that some of the lessons learned was the fundamentals of building science. I've often said publicly that passive house is building science by stealth. It was developed by a professor, and it certainly was taught to me by another professor at Hart. And it's gone on so much so that some of the folks involved in the project, which are not passive house designers, have gone in and actually sort of pointed out the fundamentals of building science in other projects besides the passive house ones. The fourth lesson that was mentioned most often at the top level was the importance of mechanical ventilation and looking very hard at overheating. That's been taken outside of these passive house projects and applied across the spectrum of projects for Kāinga Ora. This is not being done at a wholesale level, but certainly the people involved with the project are doing that. And there's an attempt to do that out throughout the organization as well. And the final thing it really confirmed in folks' minds that have worked on these projects that we can do world-class here in New Zealand. We have what it takes now. We don't need to develop more skills or do this or do that. We can actually just do it. All right, so I want to take a couple minutes to look at these projects. So this is another one of Brian's slides. So the development manager for both these projects is Joe Charleston from Kāinga Ora. And we're only going to talk about this right-hand project, which is Bonaventura, which is in construction. I'll show you photos in a second. And it's intended to be passive house certified. It's meant for pre-construction. So if they build it and they pass their tests and commission it, then I'll certify it. Effectively. One thing to notice is the staircase. So it's an open air staircase. So it means this building is actually two buildings from the passive house lens, right? It's two separate thermal envelopes with a central staircase through it. So we'll get to the lesson learned that's obviously there. I hope that that's already everyone's tip of tongue, right? In this Bonaventura project, the design team is fairly large. And here's the team. You have Precision Construction as the main contractor, Pedal Focus Architects, Kirk Roberts to instructional engineers. They certainly had to change quite a few things. The passive house design was led by Oculus, and 2PIR was the HVAC contractor, and then us brought in as the certifiers. So Dimas Rodriguez from Oculus was the lead passive house designer. And this is this design PH model with all the different 5 buildings. I guess it's 2 buildings, but I call it 5 because it's 5 thermal envelopes, because these staircases on the other side of this red block here split into multiple thermal envelopes. So if you saw earlier when Tim was talking, or Sam, I forget which, I'm sorry, they're talking about form factor, because it probably was Sam. This central block here has a form factor around 2. And obviously these end blocks, it's somewhere around 3, I think, for those. So the form factor was reasonably good for these because they're 3 stories, and this one with 2 units knocked together. But if it had been a single building, the form factor would have been considerably better. All right. This is a cross-section of the building, so you know what we're talking about. So it is a tilt slab concrete system with foam insulation between 2 leaves of concrete that's separated by glass pins. I'll show you that in just a second with a photo. And that does the wall system. So the primary structural and insulation system in this building for the walls and structure are built to last nearly forever, right? It's all concrete and steel. So the embodied carbon impact is fairly significant, but that wasn't considered in this particular project. And the roof is a lightweight foam panel system with EPS panel with, it's a Kingspan system, right? And then the foundation was typical concrete with foam pods and very good edge installation. So we'll get into that. Okay, this is what it looks like in construction. So this is just not very long ago at all. So this is the foundation, which you can see is very complicated and very heavy with edge insulation. And then in the lower left here is 2 pictures of the wall panels. This is one of the wall panels. So these go in vertically. So this is actually a 3-story tall wall panel with, I think these are the MVHR inlets. I forget, they could be the outlets, I forget. And what you see with these little pegs poking up are the glass pins that hold together the different layers of glass, concrete. So basically concrete gets poured on with its steel mesh on one side as a structural layer, 150 thick. And then you've got a foam insulation layer penetrated by these fiberglass pins. And then there's an exterior concrete leaf that's 70 mil thick. And we'll go through the lessons learned as to why that was chosen. And you can see on the edge here, you can just see the foam insulation down here. And this part goes into the footing. All right. So Bonaventura. So the lessons learned in that project, in probably every single passive project I've worked on, actually, is start the passive design at the start of the project. That was not done. This project was nearly complete design when they started doing passive stuff. So in the next project, they recommend doing early passive design charrettes, where you lay out key criteria for key consultants. So we got to that eventually, but that didn't happen at the front because passive design wasn't started at the front. The advice we'd provide would be, if you find yourself in a hole, stop digging. I often will say this myself, just stop digging, especially if I get myself in a conversation with someone that I shouldn't be having. The best thing to do is just stop talking. Right? Retrofitting passive house is really hard. So this project, at some point, we finally decided, yes, we're doing passive house, and stopped and went back and fixed stuff. But it didn't happen in a very concise way because, if you have a project, it's already well through detailed design, and you're going to go ahead and decide to do passive house. You want to do some checks and trades and studies and see what the impacts are, and you have to change the design, and what do you have to change, and it becomes a big mess. And on top of that, at the same time you're doing all these changes and revisions to the design, you have to be really careful not to disempower the original design team. I know myself, in a project I worked on a long time ago, I really got grumpy with the original design team with a project that was going to be passive house, and really disempowered them, and it resulted in really bad results for the client. So I was glad that Dimas, who managed this, was very careful to do that, and he managed that quite well. So the second main lesson learned was decide to certify at the start of the project. This would have helped to gain the trust of the design team. Designers want to do best for their clients, whether they're the HVAC designer or the structural designer, but they've been indoctrinated by previous clients, right, as to what that means when they say best for their clients. So if they're not sure if the client's going to do passive house or not, and the change is going to drive a lot of cost and complexity on site because you're retrofitting it back in, they oftentimes don't want to change, and they don't really know if your requirements are real or not. And this kind of rolls in the next part of that, deciding to certify at the start of the project. FUD, fear, uncertainty, and doubt, is real. It's important to help folks understand what's going on. If you don't do that, then they won't help you. And so it's really important to educate clients on passive house early in the project. And we would have also need to provide confidence to the design team that passive house is a hard requirement. Passive house is not partial credit. So when you're working on larger projects, you often have consultants that are used to LEED or Green Star, where most of the requirements are not required. You can trade one requirement off for another. Like if you put in environmental choice paints, maybe you don't need the bike parking, right? Passive house is not like that. Every requirement is a hard requirement. You can't trade off against another. And you really need to work to convince the specialists who need to change from their current practice. There was a lot of existing design guidelines and organizations, and Kāinga Ora is certainly one of them, and they often were developed with little consideration of performance. And some of those were changed during the project, but many were not. So for example, for this project, central open stairs were kept. It would have been better to close them in. And in the next project, we'll talk about, they did do that, and other things like that. Resource consent effectively required that wall panel system. It couldn't change to an external installation system, which we looked at because of the resource consent issues. If we could have selected a construction system to simplify the details with a performance in mind, or if we could have selected the joinery and ventilation system very early in the design and made sure they had the data to us, it would have saved us quite a bit of work as well. We looked at several different ventilation systems, many of which didn't have the data we needed to do the design work that DMAS needed to do. And finally, I won't go into form factor again because Sam did a great job of that. The second thing I'll point out is domestic hot water is the largest load to passive house. And we should focus on this more. And the next time we do a project, that's a lesson learned. We'll do that. And components aren't enough. We need systems. So it's an MVHR system, both the unit and the ductwork system. Joinery systems, both windows and doors. And structural systems is all kinds of pieces. Ducting is not easy. And yeah, anyway, let's leave that aside. Fire considerations need to be integrated at concept stage, because this can often pop up and cause lots of design slowdown while that's all dealt with, because it's a life safety issue, obviously. And watch thermal bridging from stairs, beams, shading, etc. All right, so the next project, which I'll speed along here, is Kāinga Ora. So this is, again, five buildings, but each of these buildings is built a different way. So if we look at, get this to go down. That's not a good sign. Guess I'll try restarting it. So Kāinga Ora is 5 systems. So that each building has different systems, and that CLT, yeah, that was quite quick, actually. I'm pretty happy with that. So yeah, all right, so here's the team that was involved, with the main players being Oricon, with Pablo as the Passive House designer, and Context, the architects, and then a whole bunch of supporting consultants and one of the thoughts as certifiers. Here's the 5 buildings. They all look like this red building here. There's the other 5 there. And this is Pablo from Oricon. So there's 5 different construction systems in here, and originally we called it the 5 Systems Project internally. And they range from cross-laminated timber to light timber frame, light gauge steel, precast concrete, and then a hybrid building, which uses some elements of CLT and light timber frame and other such, right? And they all had the same foundation system for practicality reasons, but the roofs and mid-floors differed as well. But I've just put the 5 different wall systems here so you can get a view of what those details look like. If you notice, they all have external insulation with a facade, a rain screen flat facade system on rails and clips. It's a terracotta tile system, which was chosen for its, although it has more body cover to start with, it has much lower maintenance cycles, so it's better life cycle carbon cost and better life cycle cost as well. So in this project is a research project, which is why you have all these different systems. And it had a slightly different set of lessons learned. So again, it had the same thing about starting with the end in mind. And this team, they thought that the thing that they would pass on to themselves is that you probably should rework the spatial plan, because as walls get thicker and as you're sitting in MVHRs and such, the spatial plan can really get clunky if you just accommodate those changes. And make the pass house constraints really explicit up front. Architects know how to work with constraints. To some extent, they love constraints. They have to, and they know how to do it, but they need to be explicit so they know what to do. They'd like to choose the construction system rather than have to pick 5 different ones, because some are certainly easy to reach with pass house than others. And to do the performance homework at the start of the project. So the team felt that one thing they did well in this project and they would recommend to themselves next time is to make sure they do the performance work up front, because there's a tendency to give a recipe for pass house, like this is how you do it. But that's very specific to topology, internal heat gains, and climate. And those answers can change from project to project. Last slide. So domestic hot water really drives energy usage. Choosing way to push the design, in other words, push the design team, is really, it's a huge shift, and we need to choose where to do that. Selecting windows early with full analysis will be really important. This project was pretty late in the certification process, and we realized that one of the window sections was, FRSI was a bit marginal. So that's fine. It meets the standard for Passive House Planning Package 10, but that was required. The design team had a few surprise requirements that were in the standard that they didn't really consider early on, like acoustics and such. Yeah, and I don't think the design team realized how much Bada Ventura helped that. I've put together quite a few social housing resources on our website, so I just give you these links. And that's that. And with, it would have been good, I think, for the design team to go and visit this project and hang out. They didn't get a chance to. So with that, Murray, do you want to step back in?
Hi, Jason. Yeah, thank you for that. It's going to be really exciting in a few years where all this work's finished, and I guess there'll be, you can do another webinar like the further lessons learned.
Yeah, it'd be great to focus on construction team lessons learned. And I know both the construction team for both those projects would be keen to do that, because they're really committed to this path.
There is a question on the Q&A. Who's the builders, I guess, for the projects? Do you know that?
Yeah, so Precision Construction is the builder for, let me grab it real quick. So yes, Precision Construction is the builder for Bonaventura, and they've already started work. And then the builder for, I want to say it's, I'm afraid I have to apologize twice. I think it's North Construction is doing the construction for Kāinga Ora, but I can't swear to that. I'm sorry.
Yeah.
I've only had one call with them.
It is great to see how, like, I think already this is changing in our industry, because I think one of the projects APL have put together the window for.
Ben
and-
Frost, yeah, sorry, Ben Frost pointed at South Base. Let me correct that right away.
Oh, South Bay, right.
Thank you, Ben. I much appreciate that. Save face.
So I know one of the projects has APL is supplying the windows, I believe. They're not
That's
even
correct.
they're not even on the market yet. So that's kind of the ability of Kāinga Ora to say, we need this in the marketplace. We're going to build lots of these if you want to supply them, and people are starting to supply them, which,
Yeah.
I mean,
Although for APL's sake, they did start producing that window and test sampling it 2.5 years prior. So it's sort of like the space program when the Apollo rocket showed up all of a sudden. They had started 10 years earlier and didn't tell anyone.
Right.
Yeah, so it was a 20-year program, not 10. So APL had done quite a bit of work before this project came along, but it was a perfect fit to move them forward and move them faster. It's been great.
Are there those PVC Kāinga windows that they have?
No, so the first project, Bonaventura, is using UPVC windows, and then went through a couple different suppliers, but those are not being developed for those projects. The APL windows are being supplied for the Kāinga Ora project.
Yeah.
Yeah.
Yeah, I'm just trying to quickly scan and see. It looks like Ben Frost's got a question about your hemispheres. Is that in your SketchUp model?
Oh no, I think he's saying because I said north instead of south base.
Oh, okay, right. Yeah,
I think I said north base instead of south base. That's all. Anyways, I think they'll cut me some slack.
Right, based in Christchurch. Oh yeah, and the thermally broken aluminium windows. Thanks, Chris, for saying that.
Yeah. So the APL windows are quite well thermally broken aluminium windows, and there was a lot of research that went into getting them to meet the FRSI requirements. So the final bit that was the lowest is the sliding mullion, of course, because that's really hard to get to work at a cost-effective rate. So also the facade. So the facade is terracotta tiles on an aluminium rail system that then has thermal brakes, which are being designed and built here in New Zealand, back to structural thermal brakes, back to the main panel, whether it's a concrete panel or timber panel or whatever, with external mineral fiber insulation. So Rockwell.
Right. So it's another example of how the industry is being developed.
Yeah.
These are
that clips. I don't know if that Clipson was designed explicit for that project, but certainly it's the first time I ran into it. And yeah, it was certainly a huge motivator because there's a lot of clips in those buildings.
Yeah, I can see there's a question there from Elron about whether the windows were thermally broken aluminium, which is answered in the chat. They were thermally broken aluminium. I think we got to that.
For Kāinga Ora they are, yes.
Yeah.
So not for Bonaventura.
Right, and I think one last maybe question from Jonathan. Are KO looking to use solar PV for on-site generation on these or other projects? If appropriate, how are they doing this?
So yeah, Jonathan, that's an excellent question. And the reality is they're complete rock stars, right? So Kāinga's got huge vision with PV and stuff, and I'm not in that space, right? But so there are PV panels on this building. There's talk about using that locally, of course, for the people in the building to reduce their bills to zero. And then you'll also talk about setting up microgrid in neighborhoods. So like potentially you can wheel PV power from one Kāinga building to another one to help subsidize power across that. They're doing a bunch of work to make sure that they pick the panels not only for cost effectiveness, but also for where the panels came from. There's not a lot of social justice issues with PV panels coming out of China right now. So they're looking at that. And yeah, so they're actually looking at trying to change the legislation in the New Zealand power market to allow sharing power from one building with PV panels to another building that doesn't, and all kinds of other social justice issues. It's pretty amazing.
See, there's somebody's already answered the question on who's providing the clips. It's Technoform. Presumably the windows are triple glazed, are they?
There's actually a variation. They're mostly double glazed.
Okay.
There are some larger panes that are triple glazed, just to make things work out cost effectively. Most of this building could have been, well, it all could have been done with double glazing. Maybe it was better to do it with what they've done, which is mix it up, right? I mean, that's the best engineering choice. I'm a purist sometimes, so I think they probably could have squeaked a few other things and made double glazing work everywhere. But it's a bit unfair to what we say Monday morning quarterback. It means, you know, after the game's over, you decide what you should have done.
Yeah.
So yeah, but so it's a mixture. It's mostly double glazed. So.
Right, thank you. And I think last question, I believe Joe's asked if there are any tours of the fire systems.
So it's not built. It's not even going to start on site for like, I don't know, 8 or 9 months. Ben would probably know. Ben Frost would probably know more than me.
Right.
So it hasn't broken ground. So the construction pictures I showed were from Bonaventura, which I very much doubt there'll be any construction tours in that project anytime soon. But perhaps they can do it at an interval or not. That's a good idea. If they do, I'd like to go.
Yeah.
So I've got one site visit planned for the pre-lighting blow door test, and that'll be it. So.
Great. And I thank you very much, Jason. We might leave it there, but so much to look forward to. Hopefully today's been an inspiration on a number of fronts, and you can see we're going to have more that we're going to be able to talk about in a couple of years. I think, Amanda, have you got one more slide to put up? But maybe we should just thank our sponsors today, Simonite. They've got some wonderful products, so go visit their website and see how they can help you. Really plugged into the Passive House space. And wait, there's more too. We've got 2 more webinars in this series. They are already available to go and join in and to book your tickets. The next one on the 17th of June is on Enefit, the importance of retrofitting. It's great to have new buildings, but most of our stock will be existing. So how do we get that to where it needs to go? And then the last one is on the 22nd of July is looking at Passive House schools and communities. That'll be highlighting the designers of the Glenroy Community Centre in Australia, which has just been certified Passive House. So that's really exciting. I'd like to just thank everybody for coming along today, and I hope that was a great learning experience and inspiration for you, and look forward to seeing you in the future. Thank you. Oh, just quickly also, I think there was a question about the slideshows. We are recording this, so we will be able to share the recording, which may be a great thing to pass on to anyone that's developing housing. Thank you.